graph the integrand and then use a known geometric formula for area to evaluate. And the reason we need to use a geometric formula to evaluate here is if we look at this integrand, we realize, oh, that's not a general antiderivative. Eventually, we'll have an integration technique to evaluate this using integration, but for now, we're going to use a known geometric formula. So we've got to sketch this. What are we given here? So we have, looking again at this definite integral, the integrand, or that function, is defined as y, or f of x, is equal to the square root of 16 minus x squared. And so we recognize that this is a semicircle. A semicircle specifically centered at the origin with a radius of 4. And if you didn't recognize that, just so that you know for the future, in general, we define a semicircle as y, or f of x, is equal to the radius, or r squared, minus x squared. And this is where the absolute value of r is the radius. Now, we want to be careful here not to get so excited that we think, oh, we have a full circle. I know the equation for the area of a circle. We have to keep in mind, what are the bounds that are given? And so our bounds, a to b, are from -4 to 0. So this is not a full semicircle, it's just a quarter of a circle. So we're now ready. Let's go ahead and sketch this. So here's our Cartesian coordinate system. We have the y-axis and the x-axis. Let's shift that over a little. So here's y, and here is x, and we're only thinking about the x-axis from 0 to 4. And so we'll try our best to sketch. So there we go. There is y is equal to the square root of 16 minus x squared. And our job is to find the area under this curve and above the x-axis. So that is the goal. How can we find this area? So we know, let's recall that the area of a circle, of a full circle, is defined as pi r squared. But we don't want the area of a full circle. We want the area of a quarter circle. So the area of a quarter circle, in this case, would be defined as 1/4 pi r squared. And since we have a radius here of 4, right, because your radius is always positive, when we plug this in, we have 1/4 pi times 4 squared. So one of the 4's in the numerator cancels with the 4 of the denominator, leaving us with 4 pi. Of course, this is square units. So therefore, we can state that the definite integral from -4 to 0 of the square root of 16 minus x squared dx is equal to 4 pi square units, or units squared. And so this is our beautiful final answer here for the area under the curve.